Just before sunrise, while the valley sits in its usual still silence, a seismograph at the University of Utah seismograph stations registers an anomaly, a low-frequency tremor at 0.8 Hz, deep, far deeper than Yellowstone's known magma system. Up on the surface, the world is tranquil. Tourists stroll across the boardwalk at Old Faithful. Children toss pebbles near the Firehole River. Families prepare breakfast in quiet campgrounds. They have no idea what is happening under their feet. 11 miles below, seismic waves move through a region scientists never mapped. A massive body of partially molten rock beginning to reveal itself. Remote sensing satellites pick up subtle ground inflation, just 2 to 3 millimeters, but enough to confirm that something is rising. In the observatory, volcanologist Dr. Fan-Chi Lin stares at the new tomography images. He does not sound triumphant. He only says, "We need to verify this, now." On the morning of March 12, 2025, Dr. Fan-Chi Lin arrived at his lab at the University of Utah to review overnight seismic data. What he found made him recheck his instruments twice. Deep, long-period waves, barely perceptible at 0.5 to 1.0 Hz, were pulsing from a depth no one had been monitoring closely, between 12 and 15 kilometers below Yellowstone's caldera floor. Lin specialized in ambient noise interferometry, a technique that uses natural seismic noise to create tomographic images of Earth's interior. The new data showed what previous surveys had missed: a low-velocity zone suggesting high melt fraction, a reservoir of partially molten rock far deeper than the well-known upper magma chamber at 4 to 6 kilometers. While Lin examined velocity anomalies on his screen, tourists photographed bison near Hayden Valley. Rangers led nature walks. Hotel guests checked in for spring break vacations. Nature does not reveal everything at once, only enough to remind us we are not in control. On paper, the signal was faint. Underground, it was the first sign of something vast. By March 15, 2025, seismologists at the University of Utah seismograph stations noticed the tremor was not stopping. Dr. Jamie Farrell, a research professor who had monitored Yellowstone for over a decade, radioed his colleague, "We are seeing resonance below the known reservoir." The tremor frequency, 0.5 to 1 Hz, was too low for typical hydrothermal systems. Hydrothermal tremors usually registered at 2 to 5 Hz. Shallow vibrations from superheated water moving through rock. This was different, deep, more sustained. GPS stations YNM and NRW, positioned across the caldera, showed uplift of 2.1 millimeters at YNM and 2.8 millimeters at NRW. Small numbers, but they matched the tremor's timing exactly. At Norris Geyser Basin, a park ranger heard a faint pop beneath the boardwalk while guiding a family past Porcelain Basin. He paused, listened, heard nothing more. He continued the tour. The surface stayed calm, but the recorders began to whisper otherwise. Deep pressurization was generating low-frequency tremor, and GPS satellites were catching the Earth's response in millimeters. The uplift was small, but it matched the tremor's timing. Maria Haskins had lived near West Yellowstone for 31 years. She remembered the 2014 earthquake swarm, over 1,900 tremors in 3 weeks. Shallow quakes that rattled dishes and nerves. She remembered the 2004 to 2009 EP lift episode when the caldera floor rose more than 7 inches, only to subside without incident. On the evening of March 18th, while preparing dinner in her cabin, she felt a familiar sensation, dishes rattling slightly on the shelf, a low vibration through the floorboards. She steadied a glass and continued chopping vegetables. Scientists knew this history well. Yellowstone had experienced at least 3 major caldera-forming eruptions over the past 2.1 million years, and dozens of smaller hydrothermal explosions. The uplift from 2004 to 2009 had been attributed to magma intrusion or hydrothermal fluid movement, and no one was entirely certain which. But this time, the numbers formed a pattern that matched neither scenario exactly. History does not repeat, but in Yellowstone, it often rhymes. Warning signs rarely arrive loudly. Most begin as a tremor too subtle for the people living above it. Dr. Lin spent March 20th comparing tomography data. On his left monitor, a velocity cross-section from 2015. On his right, the new 2025 image. The difference was undeniable. A low velocity zone indicating molten or partially molten rock had expanded in the deep region between 12 and 15 kilometers. Seismic tomography works by measuring how fast seismic waves travel through rock. Solid rock transmits waves quickly. Molten or melt-rich rock slows them down. The 2025 data showed velocity reductions of 10 to 15% compared to surrounding material, suggesting melt fractions between 5 and 30%. At Mud Volcano, children posed for photos while steam drifted gently upward from vents. The same steam that had drifted there for decades. Tourists walked boardwalks, unaware that satellites overhead were tracking millimeter scale changes in the ground beneath their feet. What satellites saw was millimeters. What scientists saw was geometry, and the geometry suggested a chamber far larger than expected. On March 23rd, gas geochemist Dr. Wendy Stovall reviewed data from monitoring stations near Norris Geyser Basin. Carbon dioxide flux had increased by 18% over the past week. The carbon dioxide to sulfur dioxide ratio was shifting, a pattern consistent with degassing magma at depth. These ratios do not move unless something changes below, Stovall noted in her monitoring log. Campers near Norris smelled a faint sulfur odor that evening. One mentioned it to a ranger who assured them it was normal for Yellowstone. And it was, usually. But the intensity had changed. Most never noticed the odor. Instruments always do. Deep magma pressurizing releases gas. The gas migrates upward through fractures, and surface emissions increase. The carbon dioxide increase aligned with the deep melt estimate. By March 26th, thermal imaging from the Yellowstone Volcano Observatory showed small heated patches near Norris. Ground uplift had reached 4.2 millimeters at station YNM and 5.1 millimeters at station NRW. Park Ranger Eli Turner noticed a ground crack while inspecting a boardwalk section. He tapped it with his boot. 10 centimeters long, maybe 2 millimeters wide. He photographed it and filed a report. That afternoon, tourists took selfies beside Steamboat Geyser's steaming pools. The steam plume rose thin and harmless, just as it had for years. Rising heat generated surface fissures. Rangers reported, scientists investigated. Ground changes began quietly. A line, a temperature shift. The crack widened overnight. On March 28th, scientists from the United States Geological Survey, the University of Utah seismograph stations, and the Yellowstone Volcano Observatory held a joint video conference. Data synthesis had reached a threshold. Emergency Manager Tina Hall, responsible for coordinating Park Service and county responses, asked the question everyone was thinking. Do we need to raise the alert level? The answer was not simple. Yellowstone operated on a 4-tier alert system: normal, advisory, watch, and warning. They were currently at normal. The data suggested movement to advisory. While scientists debated thresholds and protocols, a family grilled dinner at Madison Campground, unaware that the valley floor had risen another millimeter since morning. Conclusions did not come easily, but the tone in the room changed. The system was waking up. Below a peaceful national park, magma was moving, slow, silent, unstoppable. On March 30th, seismicity increased sharply. Between 6 a.m. and midnight, sensors recorded 127 microquakes, clustered between 3 and 6 kilometers deep. Most were magnitude 1.0 or below, imperceptible to humans but logged by instruments. Seismologist Linnea O'Neill, monitoring from the UUSS control room, muttered to a colleague that it was accelerating. At the Old Faithful Inn, guests felt a soft jolt at 8:47 p.m. The front desk received 2 calls. Staff explained that this was normal seismic activity and that Yellowstone has small earthquakes all the time. They were not wrong. Yellowstone averaged 1,500 to 2,500 earthquakes per year, but clustering mattered. To most, it was a bump. To scientists, a shift. Rising pressure fractures brittle rock. Fractures generate swarms. Swarms signal stress redistribution. The swarm doubled by nightfall. On April 2nd, remote sensing analyst Dr. Michael Poland reviewed fresh INSAR satellite data. INSAR stands for Interferometric Synthetic Aperture Radar, and it detects ground deformation by comparing radar images over time. The uplift bowl had expanded. The deformation zone now stretched 5 to 7 kilometers across. Centered near Norris Geyser Basin, Poland's screen displayed concentric interference fringes, each fringe representing centimeters of uplift. The pattern was clear. Inflation from below. At Norris, the steam plume that had been thin and gentle for weeks now rose taller, twisting visibly in the wind. Satellites do not lie, but they also do not soothe. Deep inflation pushes the surface upward. Measurable uplift intensifies thermal emissions. The deformation matched one scenario scientists hope never to consider. On April 5th, temperature probes buried near Norris Geyser Basin recorded a 3.1 degrees Celsius increase over 72 hours. Hydrothermal systems were pressurizing. Ranger Eli Turner inspected the boardwalk crack he had reported 10 days earlier. It had expanded. It was now 30 centimeters long and 6 millimeters wide. He radioed his supervisor. Tourists called it a fun Yellowstone thing. Some stepped across it carefully. Others posed beside it for pictures. People stepped around the crack. Scientists stepped toward it. Heat increase expands wood and shifts ground. Visible surface impacts follow. Thermal imaging showed a new hotspot beneath the boardwalk. On April 7th, the Yellowstone Volcano Observatory raised the alert level from normal to advisory. The decision was based on sustained seismicity, measurable ground deformation, elevated gas emissions, and increased thermal activity. Emergency Coordinator Tina Hall issued the first public bulletin. She said, "This is precautionary. There is no indication of an imminent eruption. Visitors should remain aware and follow park guidance." That afternoon, a dozen recreational vehicles left the park. Most campers remained. Precaution is rarely recognized until hindsight. Data confidence leads to alert escalation. Early voluntary departures begin. Then the lake buoy in Yellowstone Lake recorded a thermal anomaly. Water temperature had increased by 1.8 degrees Celsius near the bottom. In every crisis, there is a moment where data becomes decision. On April 10th, at 6:22 in the morning, a phreatic explosion occurred near Norris Geyser Basin. Ranger Eli Turner witnessed the event from 200 meters away. Superheated water and steam blasted 60 meters into the air, ejecting rock fragments and mud across a 50-meter radius. No ash column formed. This was not magma reaching the surface, but pressurized hydrothermal fluid finding sudden release. The explosion lasted 90 seconds. When it subsided, a new crater 6 meters wide had formed. The same steam plume that had risen peacefully for weeks had erupted violently. Seismicity dropped immediately after the explosion, but deeper tremor remained. Sometimes the threat is not magma, but the water it heats. In the weeks following the explosion, scientists analyzed what the event revealed. Seismic tomography confirmed the deep magma chamber's size, larger and more complex than previous models suggested. It was connected to the shallower reservoir, but crucially, not erupting. Ground deformation stabilized. Gas emissions decreased. The alert level was maintained at advisory. Dr. Fan Chi Lin presented findings at a press briefing. This is not an eruption. It is a revelation. Tourists returned to Yellowstone. The steam plume at Norris rose gently again, changed forever in what it now represented. The greatest changes happened where no one could see. In the monitoring station, a seismograph needle trembled faintly on the screen, steady, unresolved, waiting.